Hi everyone and welcome to the last part of chapter 4. In this part, we will learn to build a color detection game. This project is called the color detection game. Let's see how it works. Pressing button A will start the game with a 5 seconds countdown. The OLED will print a random color to the player. The player must quickly place the correct color card above the color sensor once the RGB LED's white light turns on. If the player gets the color correct, the buzzer will play an exciting tone with a well done message printed on the OLED. If the player got it wrong, the buzzer will beep 3 times and the OLED will print "try again." The RGB LEDs will turn off after the countdown of 5 seconds ends. Let's begin with writing the code for this activity. Line 1 to 3 import a total of 9 libraries for the project to work. Libraries include APDS for color sensor, Adafruit SSD for OLED display, NewPixel, and Random for generating a random number. Line 5 to 18 initializes APDS sensor, OLED display, buzzer to GP21, button A to GP0, and RGB LEDs module to GP14. Line 20 defines a sequence of musical notes in frequency for a melody. The melody will be played with the player guessing the correct color. Line 21, the array defines the duration of each note in the corresponding position in the melody note array. For example, 0.12 means that a note is played for 0.12 seconds. Line 23, the colors array contains the names of different colors used in the game. Line 25 to 28 produce an initial message to instruct the player to press button A to start a new game. Line 31, clear the RGB LEDs strip. Line 32, wait for a button start to be pressed to start the game. Line 34, clear the OLED display to prepare for the game. Line 36, randomly selects a color from the colors array defined at line 23. Line 38, prints the randomly selected color on the OLED display. Line 41, light up all RGB LEDs in white to indicate the start of the game. Line 42, prints time left blank seconds, where the blank space will be replaced with the seconds value in the later code. Line 44, the for loop iterates through a range of numbers from 5 down to 0. Line 45, this line clears a rectangular region on the OLED display at the coordinates of 70 and 50 and with the size of 10 by 7. The cleared space will be used to update the duration value in seconds located between time left and seconds. Line 46, this line displays the current value of the countdown as text on the OLED. Line 48, this line introduces a 1 second interval to synchronize with the countdown. Line 50, if the proximity value is less than 10, it indicates that there is no object detected above the proximity sensor. Line 51 to 58, if no object is detected, the OLED prints the message shown here, followed by 3 beeps on the buzzer, indicating the input on the APDS sensor is invalid. Line 60 to 61, read color data and print the red, green, blue, and clear values to the shell console. Line 62 to 73, the following lines determine the detected color based on the RGB values by comparing them to one another. Line 79, this condition checks if the detected color is equal to the random color chosen at the beginning of the game. Line 80 to 85, if the detected color matches the random color, the OLED prints the text shown here, followed by a melody iterating through melody note and melody duration arrays. Line 86 to 93, if the detected color doesn't match the random color, the OLED will print "try again" and the buzzer will beep 3 times. And now let's run the code and try our program together. Bring awareness of color blindness by letting your friends experience the project. If the player is colorblind, this project will allow them to vaguely identify the type of color blindness they are in. Collect the results as shown here. The more mistakes made for either green and red or blue and yellow, the easier it is to identify which type of color blindness category you are in. It can be frustrating as a player to receive 3 identical colors in a row. Unfortunately, using the random function means there is still a chance that will happen. We can include a check code before generating a random color to eliminate the possibility of repeating the same colors. While we are at it, let's build a function to generate the random color. This will help us keep the code neat too. This is the final code for the challenge. You probably wonder what else can be done for our fellow gamers. For one, we can improve the game by providing hints to the player. Here is how it works. The flow of the game will still be the same, but instead of lighting up all RGB LEDs in white, the first RGB LED ID 0 will light up according to the same random color. This will allow the user to color match and increase their chance of getting the right answer too. Give it a try. This is the final code for this challenge. Let's try it out. Well done completing chapter 4. In the next video, we will explore how to use the servo motor and proximity sensor. Thanks for watching and I will see you in the next video.